everyone. Thanks for joining. My name is Bongani Dube, and I'm a senior software engineer at a company called Paystack. And Paystack is a payment service provider providing payment solutions for Africa. And today I'll be talking about automated Canary tests with internal users. So just a little bit about myself. I've got 10 years of software engineering experience. I specialize mainly in back-end engineering and mainly in proxy development. So for example, authorization, authentication, request routing, and also rate limiting. I currently in the South African expansion team where we basically scaling up our services and APIs across South Africa for Paystack. I've got a BSc honors in computer science at UCT, the University of Cape Town in South Africa. I live in Cape Town, South Africa, and I enjoy solving problems using code. So just a little bit about what I'll be talking about today. So these are the different topics I'll be covering, namely what a canary is, why would you want to use a canary, my journey in canary testing, and also a comparison between canary tests and integration tests, and a comparison between the different types of canary tests that you'd find. And I'll also just be taking you through a demo using Datadog on how you can write your own automated canary test. So you're probably wondering, what is a canary test? So back in the day, 100 years ago, miners used to use canary birds in mines to prevent or to detect harmful gases, such as carbon monoxide, before it impacted them. And today we use that mine canary as an analogy to describe canary tests. And basically, canary tests are tests that detect issues before real users do. So you're probably wondering why you'd want to use a canary. So these are the different things that you'd want to use a canary for, which is to improve the overall reliability of an API, so such as the availability and also latency, and also increase the confidence of users in using that specific API. So for example, detecting the actual issue before real users find out, and increasing the confidence in allowing you to actually fix that issue. It also reduces the risk of releasing any API that has any issues as well. So a bit about my journey into canary testing. So I've got a background in software engineering at AWS. I used to be a software engineer there. And there we used to build API canaries to test building new regions. So if you're familiar with AWS, every time a new region was launched, we used custom canaries to actually test out that region and make sure that all the services were working correctly. And currently, I am building and monitoring API canaries for Paystack. And these canaries basically allow us to monitor any downtime with our APIs. So you're probably wondering, what is the difference between integration tests and canary tests? A nice example that I like to tell is that if you're familiar with the CI/CD pipeline, integration test is on the CI portion of the pipeline, so continuous integration. And the canary test is on the CD portion of the pipeline, which is continuous delivery. And as you can see, they have got an example of the differences of a canary, which is a rock and also the rock. So you're probably wondering, okay, so what does that mean? So basically, integration tests are tests that you'd usually run before you actually deploy a feature. And Canary tests are dynamic tests that would usually run even after you've actually deployed the feature to monitor latency, availability, and any networking issues. So yeah, the different types of canaries that I've worked with, I'll also be going into details for each of these. The first one would be a custom API canary, which is basically your own canary that you'd run on a scheduled customizable region. Then you get the cloud canaries, which is AWS API synthetics, which uses AWS Lambda scripts to run on any AWS scheduled, any AWS region. Then you get Datadog, which is currently what we use at Paystack. And Datadog allows you to run API scripts that run on a schedule in the cloud as well. So jumping into the details of each of these, custom API canaries. So the usage for this would be to test APIs inside an intranet. So as I described before, with the reason why you'd want to use a custom canary is because it's not linked to any cloud solutions, so you don't need to deploy to any publicly available environment. You can test this in any intranet environment. It also tests features not available to users, and you can also replicate users' environment and test availability. So in comparison to cloud solutions, where you test in a environment that is stable and all of that, with custom canaries, you can actually test in an environment that you design yourself. So the pros and cons for this is that pros, obviously, they link to the non-dependency of publicly available APIs, so you can test this on an API that's not exposed to things like a API gateway or anything like that. And also, it's not dependent on any cloud services. It also allows you to add feature flags and also short-circuit your APIs if you need be. Some cons, yeah, obviously, with this comes a lot of work in terms of just the maintenance of the API, such as creating your own custom scheduler or job, configuring and deploying into your own environment, and also maintaining your own alerts and logs. So this is, so I'll be taking you through the design of what a custom canary would look like if you want to build it yourself. So in the sort of foundation of a custom canary would be a kernel. So this can be a Linux kernel. And then on top of that, you have three main components inside that, and then two outer components, which you'd basically use for logging and detecting any issues. So just to talk about the three main components, you get the job scheduler, and then the job schedule will schedule jobs, automated jobs to run the Canary tests runner. And that would run under a virtual machine. So in this example, I used JavaScript, but you can use Python or any other language that you'd want to design this with. And obviously, while running the Canary test runner, you can actually send the logs to any DB that you'd want to, and also expose the assertion. So if a test passed or failed in a web UI that you'd want to add as well. So a little bit about AWS. So this basically, in comparison to a custom canary, you'd use this to test publicly available APIs. And also check the availability and latency of those APIs. Some pros and cons for this. So since AWS is a well-known service and it also offers you some services that you can leverage to build these canaries, such as AWS Blueprint, which basically helps you to have a automated canary generator for a specific protocol. So if you're designing for APIs or HTTP, it generates the the response for you. You can also leverage AWS Lambda, so it's deployed via AWS Lambda, so you don't have to configure your own environment to deploy this. You can also get alerts and logs via CloudWatch. Some cons, obviously, as I said, you cannot test in an intranet environment, so an environment that's not exposed to the public. It's also specific to AWS regions, and it also bears a lot of costs. As you know, AWS, you have to manage your costs. So there's a lot of services involved in actually building this Canary, such as AWS Lambda, CloudWatch, and also AWS charges you per test that you run. So you can imagine if you've got tons and tons of API requests, the costs can get really high. And just the steps, just to visualize how this looks like. So you can use CloudFormation, obviously deploy this, but just to depict how it looks like on the UI, this is the blueprint that you'd use. You'd basically go to CloudWatch, select the blueprint that you'd want to run. For this example, used API Canary. And then after that, you can specify the request that you'd want to run, and also the schedule that you'd want to run those tests. And also, it generates a basic Lambda code for that specific request that you'd want to run. And so the first portion would just be importing all the packages that are needed to actually run the test. And then, as you can see on that line 2023, it gives you a basic assertion statement of when a test passed or failed. So all this is auto-generated initially, but you can also customize, obviously. And then it also builds up the request in code as well that you'd want to run. So a bit about Datadog. This is what we use at Paystack to monitor Paystack's availability, Paystack's availability for the public APIs that we have. And you can also check errors like authorization errors or like any type of weird errors that you'd want to test as well. And the pros and cons for this is that the pros is that you can test up to 8 networking layers, so not just confined to HTTP. You can also deploy via Terraform or Datadog UI. So also similar to AWS, it's not confined to, you don't have to build your own environment to deploy these. And you also get alerts and logs via Datadog. And a nice thing as well is that you can test custom synthetic locations. So by that, I mean, like if you look at the custom Canary, where there is the data store, you can imagine the data store being Datadog. So you can swap out the data, you can build everything else and swap out the data store and add Datadog as your data store. But obviously you have to expose that endpoint to the public. So moving on to the cons, I guess, is that you obviously cannot test this in an environment that's not exposed to the public. And also, it's hard to test APIs. So this is one of the challenges that we have as well, requiring two-factor authentication. So for example, if you need an OTP for a specific API to be validated, it's very hard to test that, but we sort of mainly just mock the response for those types of APIs. So there is a way to do it. It's just that there's some hurdles there. And also there's some cloud costs involved for this. So it's not as bad as AWS, but there is some cloud costs involved for using Datadog. And just to run through the steps required to build this, you can also use Terraform, but for this example, I'll also show it in the demo. You can actually add the request that you'd want to run the test. Then the next step would be obviously to add the assertions for the specific test. So the initial assertions, when you run the actual request, are auto-generated. but you can also add any additional assertions that you'd want. For example, if you want to test a specific data in the response body for the request. And fourthly, you can also extract variables from the request. So this is important if you're running multi-test API Canary, so tests that depend on the previous API request. You can actually store the variables and use it in the future requests that you'd be running. And then now it's time for the demo. Oops. Okay. Okay, cool. May the demo gods be with me. Cool, awesome. So this is Datadog. I've already signed in. And what you do initially when you're creating your own test is you go into the UX monitoring tab. Then you'd open synthetic tests. And then under synthetics, you just create a new API test. As you can see, I've selected new multi-test API. And then with regards to the user itself, so you can actually specify any keys that are required to actually run your test in variables. As I've done here, I've stored my key to actually run the test in a variable. And you can also name the actual test that you're running. So yeah, just to backtrack, for this specific test, what I'll be doing is I'll be working on the Paystack payment page. And this is basically a page that users would go into when they want to make any payments using our APIs. And in this Canary test, I'll just be fetching a payment page and getting the payment page, so fetching all the payment pages that are associated with one of the internal users, and getting a specific page, and also updating the page name for that payment page. So this is the payment page as it is currently, and what I'll be doing is just changing or changing the actual payment page here to something cooler, I guess. And yeah, so firstly, what you do is you'll name the page. Then you can select the environment that you'd want to test against. So here I'll be calling the Paystack prod environment. And you can also select the location. As I had described before, you can select the location that you'd want to run your test in. So in this example, I'll be running the test in Stockholm and AWS. And then you can define the steps that you'd want to run the test. So inside here, as I had showed in the previous presentation, you can specify the request that you'd want to run. So I'll just type this in. So this is just calling the Paystack page API. And under advanced, so as I said, this requires the user's authentication or authorization rather. So I'll just be adding the authorization header there. And then when you want to call the variable, you just use 2 curly brackets and it will give you options of the variable that you would want to call. So I'll be calling page using that, and just to test that this request actually works, I'll just be running test URL. And as you can see, it actually worked. Oof. And it gave me a response of the actual request that I sent, which is a 200, and it generated the assertions for me. So just to walk you through some of the assertions here, is that the first one that it generates is basically an assertion of the latency that you're expecting from this API. And the next one would be the actual status code that you'd be expecting, and also the actual content that you expecting from the API. You can also add your own assertions here. For example, if I choose, let me rather choose it from the actual body itself. So you can go to the body and choose, for example, I want to make sure that every page has first currency is ZAR. And then when you click on that, it will show you that, okay, for this specific request, I want the page to always contain a ZAR variable there, which it has passed. And then the next step would be to decide if you want to continue the test if the steps fails. So this is great when you basically creating resources for your Canary, and even though there's failures, you want to clean up those resources. So you select this option here. And then, as I had said before, you can actually extract variables from the actual page itself. So in this example, I'll just be creating a variable called payment IG, which would be changing, I believe. So to actually create the variable, I would like to change this ID, this name here. So selecting that ID and saving it in a variable. And then you can just click save there. And if you open that again, you'll see that payment page is now populated with this ID here. And I'll just save the step. And then on the next step, what I'll be doing is just to verify that when I fetch that specific ID, that it returns the response that I would want. So let's quickly do that. Paystack page, and again, as I mentioned, if you want to call the variable, just open the curly brackets, and as you can see here, I've got now an extra field which is extracted variables, and I'll have to run all the previous tests for this, so that it extracts that variable from the previous test. And I'll also have to specify the authorization. So obviously, when you're using Terraform, you don't have to do this over and over, but for the sake of the demo, I'll just adding a private key for the request itself, and running the tests to verify that everything is working. As you can see, I was able to retrieve the actual page itself, and the response is as expected, 200 response. The response body has retrieved the page that I'm looking for. And then for the final step, I would like to actually do an update for that specific page. I would like to update the name of the page. So how I'll do that, instead of a get, in this case, I'll be using a put. And then specify the actual API request page, and also the page ID. And in this example as well, I want to run all the previous tests. And the bearer. Key. And so the difference here is that I would be adding a request body to my request to actually do the update. So I would be naming this to something cool. Okay, cool. Yeah. Hopefully that's cool enough for you all. And then after that, I just want to verify everything is correct. I've got the authorization, the page ID there, which is correct, and then I'm running all the tests. and then I'll just be testing that response. Okay, and that looks good. And then just to make sure that it actually did something to the payment page, I'll just be refreshing that. And as you can see, it updated the payment page there. Looks like the demo gods are with me today. And yeah, as you can see, there's some assertions that it populated there as well. And then I'll be saving that step. And then moving on, so now that all my steps are configured, this is where the nice part about Canaries come in, where you can actually, add alerts and also schedule and also roll back monitors and things like that for your Canary. So you can actually, define the actual trigger for your test. You can configure the monitors that you'd want and also the people that you'd want to actually notify for your test. And after you've done that, you can just click on create. And in the next few minutes, it should populate the initial request for me. In the next few seconds, rather. Okay, cool. Just double checking. Okay, it's taking longer than expected. There's something happening now. Okay, cool, awesome. So as you can see, the tests have started running, and basically each and every request here is a request for all these different APIs that I've called. And yeah, that's pretty much the demo and the talk itself. Thank you. Yeah, so are there any questions, comments? Yes?
How do you prevent your tests from filling up your production database with test data? Do you run like a cleanup script or something?
So currently, actually, that's one of the issues that we sort of like trying to prevent, because as you know, it's quite easy to actually generate a test, but writing the correct test that actually generate the correct data for you is it's quite an interesting problem to solve. So what we are doing right now is just to make sure that we deprecate any sort of like tests in Datadog that are not meaningful, and making sure that those requests are not filling out, our cost, our expenses. But in terms of actually cleaning up the tests themselves, I believe Datadog has a retention policy associated, which is, I believe, a month, but there is a retention policy for those specific logs as well. Yeah. Any other questions? Comments? Yes.
Do you run your Canary tests against production or staging environment, or against what do you run it?
Yeah, so currently we run it against our production APIs. So these are mainly just, so we use Canaries to make sure that we detect issues that happen in production, before it causes any major issues for our merchants or customers. So currently we're building that sort of list of APIs that we run in production. Yeah, So that's...
Can I give a follow-up question?
Yes?
With regards to writing your own canary, let's say you need to do it because, okay, I see Datadog does support like gRPC, but let's say you have some communication technology where the protocol is not supported. Like let's say you want a canary test a Kafka topic or whatever. Would you write the application to test that and then to prevent the, I'd say, PT of writing your own scheduler, just put that application in a Azure, AWS Lambda, so that the Lambda can schedule it for you, but you have your own scheduler, or I don't know if I'm making sense.
Yeah. So it's really up to you. You know, as I showed, like with the custom Canary, there are certain portions that you can extract and you can use yourself, and also cloud services offer you the ability to use their logging services if you want to, or they, you know, if you want to use Lambda, you can use Lambda as well, and maybe store it in another data source, like, you know, if you want to use the monitoring from Datadog, but the fancy Lambda scripts, you can also do that. So it's really up to you, but I guess the most important thing is just to answer the question of like, where do you actually want to test the publicly available APIs, or do you just want to test that everything inside your systems is working correctly, so the integration of your systems? Because you can also, like I've seen examples where people actually add a Canary test inside their system, you know, the Canary test runner inside their system, and they maybe, for example, they're just testing, you know, that the actual file system is moving files correctly, you know, so you can actually build that Canary test runner inside your system. So it's really up to you on how you'd want to frame it. Yeah?
Just another one. Just based on your own experience, what would you say it's, what is the disadvantage of, for example, in your CI/CD pipeline, once you've built your artifact, you run a Terraform script to deploy it, or however you deploy it, and then in that same pipeline, like run some script commands or whatever to test the APIs, what's the advantage and disadvantage versus having a separate service doing the test for you versus containing it all in one pipeline?
So containing it in one pipeline, I think from the experience of like just building regions, I think the advantage there would be the ability for you to, so for example, if you're building a custom Canary, right, there are certain things that have not yet fully deployed yet. For example, you haven't exposed that API to API gateway or something like that, or you haven't exposed you know, some of the actual calls in your Canary, you know, to the public and things like that. So in those cases, the advantage would be to build a Canary that is not exposed to any of the cloud services, so that you make sure that when you're testing before going to production, that those systems are working correctly, you know. And obviously the disadvantage is you have to like maintain that. You have to write monitors and alerts that actually test the right things, because you don't want to be blocking the pipeline for unnecessary things. And the advantage of just doing it in cloud is that you don't have to set up anything. Once your test goes to the public, you've exposed your test, you can go wild with actually using any external services, but obviously the disadvantage of that is the costs involved, because the external services use a lot of other services. As you saw there as well, Datadog uses AWS regions. So I only selected one region there because I don't want to, have a huge bill for Paystack to do the actual test. So you have to be cognizant of those different things. Yeah. Cool. Are there any other questions, comments? Cool. Yeah.
So when it comes to the internal API testing, like what's the limitations there? And then how do you guys do it? Do you only test the external facing APIs, or do you have like Canary testing for all of your, let's say the APIs that you get called by your website, your dashboard, for instance?
Yeah, so just to talk through the limitations of testing a Canary that depends on third parties. So that's sort of like the biggest limitations of Canaries, is that like when you're testing a public-facing API, for example, we've got a charge API, and in the charge API, you need the actual user to authenticate the charge itself. For example, if you've ever made a payment using an online system, you'll need to specify the OTP and things like that to actually make the charge go through. So a way to sort of bypass that would be to mock the response. Instead of actually going to the third-party provider, is actually to mock the response that you actually made the charge. So those are some of the things that you have to think about when you're designing a Canary test in just the public-facing environment. So that's how we deal with sort of like issues that only testing public-facing APIs and making sure that when you actually hit that endpoint. Also, another good thing to note is that like we use feature flags for some of our APIs as well. And by that I mean if you're actually testing a specific API, making sure that internal user or that integration or private key is within a feature flag that allows you to go through a specific code path that doesn't require any sort of like third-party issues. And also third parties come with charges as well. So if you're actually hitting a third party, you actually incurring costs for that API. So those are some of the limitations and things that we sort of like looking at and are working at when we're actually designing this Canary test. Yeah.
So the other thing is, let's say you're having microservices within your own system. So do you test your system on a higher level, or you're having like tests for each individual API within this? Is, let's say you're adding a user, we have a validation system API which is internal. Do you write tests for that, or just writing tests for the exposed to your browser, the APIs that are exposed to the browser, and then the one that is being called to add the user?
Yeah, I guess that's the thing. With the nice thing about microservices, you can just test from like the start until the end of the actual DB that you're calling or something like that. Canary. So obviously we use other tools as well. So we're not just using Canary tests. We've also got contract tests that test the ability. Of like making sure that the systems are interacting correctly, and we also have like unit tests that test like specific components and stuff like that. So Canary tests specifically just test the API code path. So that code path can be calling other microservices as well, within the actual code. So it's not it obviously is not specific to that code path that you'd be calling for a microservice, but obviously there are certain APIs that just get users, that just gets the user exposed to that. So in a nutshell, in summary, we basically just test, we're using multiple approaches to test our microservices. Yeah, cool. Cool, it looks like time is up. Thanks a lot for joining the talk, everyone. As you can see on the screen, feel free to email me, and we also are part of the actual, what you call this, we've got a booth at the ground floor, so if you want to chat to us, feel free to come through. Thanks a lot.